What is going on, Diesel Nation? We're excited to have you guys with us today on the Diesel Podcast. If you're watching this on YouTube and aren't subscribed, make sure and click the subscribe button, like, comment, let us know about the episode. If there's a particular guest or topic that you'd like to have on, we're always checking your feedback on there and love to be able to take those suggestions and then get them onto future episodes. Before we get to today's podcast, I wanted to give a shout out to a couple of our sponsors that help make the Diesel Podcast popular. The first is Target Sports USA. So if you're into the outdoors, hunting, taking road trips, going to the range, they're a great company. I've actually been a customer of theirs from way before the podcast even started, and they have some really cool benefits. So they have a special link for us. You're going to find it down below, or you can go to targetsportsusa.com/dieselpc, and you're going to get a free cleaning kit on your first order by going to that page. So it's a great way to get some cool maintenance items that you're going to need for your toys, and they have a ton of different choices, whether you're going to be hunting or going to the range. There's incredible ways to check inventory, be able to see what's in stock, different brands, different options. They also have something that's really cool, which is a membership. Now, the membership is something where you get free shipping on every order. So whether you want one box or you're getting 50 boxes, no matter what it is, you get free shipping on it, plus an 8% discount automatically. And there's different times during the year where that discount can go up to 16%. So it always helps to save a little money, get some really cool gear we need for our hobbies out there. Part of being a member is you also automatically get entered into 2 giveaways. One is an all-expense paid hunting trip to Colorado. So that includes airfare, meals, everything that you're going to need. It's 6 days long. It's really cool. So I know a lot of our listeners are going to be interested in that. You guys really love the outdoors. So you're automatically entered for that. Plus, they do a truck giveaway every year. So it's a Ford F-150 that they give away to members. And I think the last one, he was a member for 7 months and got it. So if you're existing, new, you join up. Great way to be able to save some money, get some free shipping, and get entered into 2 really cool giveaways. Also, Kershaw Knives, and this kind of goes hand in hand with the outdoors and hunting, fishing, EDC, things like that. But Kershaw Knives has a 40% off MSRP code just for you guys. If you use code 2024diesel40, you get 40% off MSRP. Just go to kershaw.kaiusa.com and use that code. They have a bunch of choices for different opening mechanisms, blade steel, blade shapes, handle materials, and a whole lineup of knives that are designed to meet any budget. So if you're in the market, definitely head on over to their website, use that code, and get 40% off MSRP. All right, let's get to today's podcast. Cass and Adam, welcome back to the Diesel Podcast. I know there's so many engine questions. I thought it'd be cool to just kind of rattle a bunch of them off to you that we get all the time. I don't know how to answer them, so I'm sure we'll have a great conversation today, but welcome back to the podcast.
Always good to see you.
Thanks for having us.
Yeah, there was, Adam, you were telling me a little bit, it kind of coincides with a question that we've gotten before, which is fuel in the oil. And a lot of times when I get the question, it's about somebody who's, DIYing, their truck, they go do an oil change, or they're paying attention to where the oil is on the dipstick and they notice it's a little bit higher. But you guys had a totally different perspective on it and some things you guys are seeing. So I thought that would be a great place for us to start, maybe not necessarily even on a new engine. It could be, but also just trucks that are out there and people are maintaining their vehicles or just trying to stay on top of kind of a failure that can happen. But what do you guys see on your end with that?
So I don't want to step on Cass too much here because he definitely knows a lot more than me, but I spend a lot of time on the phone doing tech calls basically. And for whatever reason, over the last month, I've probably gotten 5 calls about water draining out, or not water, excuse me, oil draining out when they're doing an oil change because they had some sort of knock or tick. So they changed the oil and they said it drained out like water. And I don't mean gray or brown. I mean pure black, but the consistency of water. And right off the bat, you know what that is. That's fuel contamination in the oil. I mean, Cass, you want to talk about what causes that and what damage it causes and how to prevent it? Or
what typically causes it? Fuel's getting in the oil. Yeah, if it's like, to be a little bit of a smart aleck, yeah, when it comes out and it looks like fuel, it's probably fuel. But that is detrimental, obviously, to the engine. Nobody wants to have that mix. The big thing about it is understanding what oil has the 3 major principles of what oil its job is and what its function is. Not just lubrication, not just rust prevention, but also heat dissipation, There's a lot of things that oil does, and understanding the job that it has, it cannot do its job if it is being contaminated. And diesel fuel, the problem with, okay, so if you were a guy that ran nitromethane, right, and you were a racer, these guys are running on the track and they're just dumping just loads and loads of fuel down their race cars. And then when they get to the end of the track and they take this thing back to their pit, what they'll do is they'll drain the oil out. And I mean, a bunch of the old timers always talk about this, and they will basically lay the oil out and the fuel will evaporate, right, from their oil. And they will put that same oil right back in and run it again. Well, that's great. That's if you're a gas guy. The problem with it is that diesel fuel has a certain specific gravity, and that specific gravity of the fuel is about the same as your oil in some cases. So with a thinner oil, and so you can't do that with diesel fuel. It's not like it's going to evaporate. It's an oil-based fuel, obviously, but it's not. It does not have the ability to separate. So you can't use a centrifuge to take that oil and spin it up and be able to separate it, because the specific gravity of diesel fuel and oil are so close. You can't separate it in a centrifuge. And so all that being said, it does though, however, when we talk about the viscosity of the oil needed for a hydrodynamic wedge, which we talked about this before, but hydrodynamic wedge is basically no different. The best illustration I think I ever heard of that was like Dan Bagley give an illustration of how a wedge worked in a door. If you kick the wedge underneath the door, to keep the door from opening, it picks up on the door, and that's no different than or a skier. That's another great illustration. But it actually never comes in contact with the bearing. It has to ski across that surface, and it uses a hydrodynamic wedge to pick the crankshaft up off of the bearing. And in diesels, we see that there's a lot of fuel intrusion in different ways. Some ways are from, a guy that's running a very large injector, and we start seeing fuel get past the ring. But what you're talking about, Adam, is really not really related to that. It's more most likely we're talking about guys that have just installed their engine a lot of times, or just did some service repairs, possibly put injectors in, possibly put a fuel pump in. And there's certain engines that are prone to this more so than others. And those engines are typically ones that the fuel systems actually run. They run. Can you close that door for me if you don't mind? Sorry. That typically the fuel system runs under the valve cover, like a 6.4 liter, like an LB7, like a Cummins. And I know most guys are out there going, "Oh, what are you talking about? Fuel lines don't run on top." But anybody that's seen a 503, 505 injector with a body cracked and it starts dumping fuel into the crankcase, it becomes a real problem. The reason why you hear about it more so with the Ford guys, though, than you do with the Cummins guys is because the bearing area is larger for a Cummins engine than it is on a 6.4 liter. And so what happens is it's like a bed of nails, right? If you have a bed of nails where there is a nail every eighth of an inch or every quarter of an inch or whatever, you can support a lot more downward force, without being impaled. But if I took all those nails out, but a couple of them, at that point in time, you are going to have a very bad day. It's going to be a lot more uncomfortable for you, right? Well, the bearing area and the oil kind of share a synonymous kind of relationship there that the nail does. And so because of the Ford platform, the bearing area of that platform is less than that of, say, a Cummins engine. It does not support as much. And so you tend to wipe out bearings faster on a Ford than you do a Cummins. And that's just the truth. So what can you do to combat those things? On our install guide, that's one of the key things that we talk about. Adam, one of those things, and let you touch on that, kind of some of the things that we do that we can find out about the problem before we have it, or before at least it takes effect on the engine.
So it's what we have in our install guide is we require really all of them, but really it only matters so much on LV7 and the 6.4. Yeah. To activate the lift pump, to kind of pressurize the system a little bit and let it sit for a little while with no oil in the system, drain plug out. So you activate that lift pump. We say for half an hour. If you see anything come out that drain plug, that's fuel that's going to contaminate your system. And so we're just checking to make sure that those lines underneath the valve cover are not leaking is the main deal. One of the guys though that I had called put brand new injectors in and then immediately had this issue. Mm-hmm. And I, just because of my background and where I've worked previously, I know that if that happens with a brand new injector, there's probably some sort of contamination in there.
Yeah. I've had Ford, we had problems with, and you know, I say that too, and I need to add this, a 6-liter, you know, the great thing about a 6-liter, and I've often said this, Patrick, on the podcast before, what Huey stands for is helping engines against uneducated installers. It's not, you know, hydraulically actuated, electronically controlled unit injector, but really it does. It just helps engines against uneducated installers, because it doesn't matter if the thing's got a drop of oil in it. 7.3 is going to shut off. 6.0 is going to shut off. 3126 cat's going to shut off. DT 530, it's going to shut off. It doesn't have to have it because, I mean, it obviously it has to have it. And that's the beauty of it. It has to have the oil. 5.9 Cummins does not care. It will run that sucker into the ground, burn it, seize the sucker, move up. You know, same thing with the Duramax. It's going to do it because it is a high pressure common rail system. But I do remember you talking about injectors. I remember one time we had a guy, and I'll never forget this as long as I live, because the guy had a breathalyzer on his truck, and I had to breathe into this thing for like a week trying to diagnose this thing. It drove me nuts because he would come in, they do an oil change, and it was fine for 30 days. After 30 days, this thing would come back, and it would always come back with a cam crank sensor issue. I forget the code right off the top of my head on it. But anyways, it would come back. I think it was coming back with a code for maybe cam sensor or cranks. I don't remember. Anyways, what was happening is a brand new set of Ford injectors. There's internal O-ring inside that they had left that O-ring off, not the external one, but the internal O-ring inside of it. And it was leaking and it was filling the crankcase up, but it would take 30 days for it to fill up. Now, if that was a 6.4, it would have burnt that dude to the ground. I mean, it would have smoked that engine. But because what happened is that it would fill up so much, and then that you would get a whipping effect, right? So the reluctor ring was picking up that oil or fuel, right? And it was slinging it around. It was basically prohibiting the cam sensor to do its job and be able to pick up, because it cannot see the tone ring through this film of diesel fuel. It's not intended to run in that. And so it would shut the truck down and it would get towed back, and I would be puffing on a breathalyzer again. So it was an experience, but we figured it out there at the very, finally, but it was weird. It was a weird problem.
When you do get fuel in the oil, is it something that, I mean, if you're noticing it on an oil change, has the damage already been done? Is it one of those things where maybe you can get by catching it quick enough, or it's just kind of a sign that bearings have been damaged, other things, and it's just going to need a rebuild?
That's a hard question to answer because you don't know how long the engine's been ran. You don't know what the duress that the engine was under when it did, but the viscosity and you don't know. So one of the things that you can do is to see how bad it really was is to check what the cetostoke level of the oil was. So when you do an oil analysis on it, those are one of the things to check. And it's a cetostoke level basically gives you an understanding of what the viscosity of that oil looks like, what the type of contamination that we're looking at. It doesn't have anything to do with maybe particles, different contaminants, different metallurgy that's in the oil or anything like that. It has to do with just typically we look at that particular parameter for that particular number for fuel contamination. And I've seen engines that literally came in with 28 quarts of oil on a 6.4, and they went out and they were fine, and there was nothing was detected. But typically what happens is it does sacrifice that top substrate or that top layer of that bearing. And it wears that off pretty clean. Diesel fuel does a great job for cleaning stuff, but not so good for lubricating on certain surfaces. But it's not to say that the engine's 100% destroyed, but again, it is application specific. So it's really, really hard to answer that one. I've seen engines that I thought, well, this was it, and then still managed to live. However, I'm sure they would have lived even longer had it not been for the effects that they suffered.
So I was talking to one customer literally yesterday on a Sunday that had that issue. And I told him kind of what you said. We don't really know. I told the guy to get your oil tested just to prove that what I thought it was what it was, and fix your fuel leak, whatever it may be. Sounded like he had a clogged injector that was just spraying too much out of some other holes. And I said, well, the problem there could be now you're washing rings out. You could be doing more damage to the piston, but whatever. I said, fix your fuel and then flush the engine a couple times with oil. So do a couple oil changes. Is that because my biggest thought there is it's getting in a lifter and going to destroy those tiny little needle bearings in the lifter. If you hadn't already destroyed the rest of his bearings, that lifter's real high on the list.
Yeah, it definitely is. Yeah, especially when you're talking when you're talking the same lifter that runs in the one that we all know and love that was a 903, I think. Anyway, 6064 lifter 773. We don't see as much problem out of the 67, and some of that is because of the surface speed of the lifter. The axle is larger, the wheel's larger, and the surface speed of that lifter is actually a little bit slower. Um, it's like having a bigger wheel. It covers more ground. But yeah, the guy's engine's gonna be nice and clean. That's for darn sure, right? So as far as the flushing thing goes, yeah, it's not a bad idea because it's hard to get that stuff out. When you do that, you also got all that oil that's in an oil cooler. So, you've got maybe a quart and a half that may be sitting in your oil cooler, depending on what type of engine it is or whatever. But you still have another quart and a half, and that really goes a long ways. And you're talking 10% possibly that may be fuel contaminated. It's not a bad idea to go ahead and change it and get it flushed out, like you said.
You actually bring up a good point. It's a good cleaner. So if it happens to an older engine, excuse me, you're now taking any junk in there from, say, an extended oil change interval, and you're now pumping it through the rest of the engine. I could see it foreseeably causing clogged oil coolers, turbo damage, anything with a small passageway.
I can see it, breaking some material loose and maybe getting into a lifter. I don't, it's really hard to say, especially too, where we start seeing that stuff start to, it literally could get in anywhere when you think about it. Cause if you think of guys really not done a good job about changing his oil and you start seeing the coagulation that kind of starts to occur, it can get nasty. I mean, that stuff can get really, really bad. So could it do? Yeah, it could stop an oil cooler up, but you've probably got bigger problems to begin with anyways on that. You probably had some issues, with oil cooler temperatures and deltas like that already. But yeah, it's a bad situation. It's not, and it's a preventable situation, but it's something that you need to keep your eyes on. I was always, whenever I did an engine install, I would always take the truck and I would run it. I would run it from the shop to maybe a mile down the road, and I would immediately stop. And I would check for any leaks. You know how it goes. It doesn't matter. You're putting an engine in and you're trying to do it. Sometimes you're mixing old parts and new parts to get this guy back up and running. He doesn't want to replace every single thing on the truck, but you want to make sure that nothing got missed. So you're crawling underneath the truck, you're looking and seeing, is there anything on the ground? Have I got any kind of leak? Have I got anything going on? Any unusual noise, whatever. But it's a really important thing when you start opening up the engine. The things that I find that people have problems, if you look at engine failure in aviation, typically engine failure in aviation, I think the highest rate of failure is like somewhere around 300 hours on the engine. It's not even the 50-hour time, but it's around the 300-hour interval on that. And because you have parts that are breaking in and different things that start to surface. So even when you install the new injectors and the new fuel lines, that's a very critical time for you to be consistently checking your oil on a daily basis. If the truck had 50,000 miles on it, fine. Check it every couple of weeks, whatever. Maybe even between changes. I don't know, but I know that if I was putting a new engine in or I'd just been in that engine, I would definitely be looking and seeing what I could, seeing if there's anything changing.
The place my mind goes, I was going to say, the place my mind goes to next with this is, when are people going to be looking at their oil outside of regular maintenance? So I think if I call you guys up, I need a long block, I order one in. How do I one, do the break-in, because I'm going to probably look at the oil when I do that, and then moving forward. So break-in's a huge topic, and I don't know a lot about it outside of like if you buy a new vehicle and what it tells you in the manual is if you're buying it used, it's already broken in. But you guys are building engines, shipping them all over. How does somebody break in their engine? Is there a specific process you guys have for it that you want to see? How does that all work? What's the best practice for it?
It's a good question. We get that question a lot. I know that Adam, you probably get that question. Probably maybe the most common question you get asked. And break in, it depends on who you ask, how they're going to answer that. As far as I'm concerned on break in, there's a lot of things that have changed. That years ago, when you broke in an engine, they would tell your break-in procedure was quite a bit different than what you'd always hear people say. Well, you got to seat the rings. You got to seat the rings, right? Well, that's true. You do. I mean, there is basically a lapping process that is occurring while you're running it. But we do a lot of that break-in already for you, and that's all in the honing process. And it's important to hone an engine with a plateau. Not to get really super complicated on this, and for the people that are listening, they probably put them to sleep. But what it basically amounts to, this is really one of those things where you just need a visual representation. But if you can imagine, well, we call it peaks and valleys for a reason. But the cylinder wall, if you were to do a cross-section analysis, you would just see basically a squiggly line. Those peaks are what your ring is actually seeing. And I remember when I first got into this business, I took my engines to a certain machine shop, and they didn't have what is known as a profilometer. And I've said this before: if you're going to a machine shop and they don't have a profilometer, you don't need to be using that machine shop. It's really, there is no possible way for you to know if you're doing a good job or not. It's literally just the luck of the draw, and you're not going to get lucky. And the reason why you're not going to get lucky is because what you're doing is the same thing every single time. And you have to at least get it right the first time and say, okay, this process is good. We're going to use it from here. They'd have never known, right, whether it was good or not. So they had no way to qualify it. But a profilometer it looks like it's a device that it's got a little needle on it, right? A little finger that comes out and it rakes it across the surface area, and it measures your surface finish. And you could speak for weeks on end about that, but the ring sees that peak. If it is not plateau honed correctly, it will prematurely wear that ring out, and that's when you start consuming a lot of oil. In the shop that I took my engines to when I first started, they didn't properly break the oil, or they didn't plateau hone it, and it wound up wearing the rings out. And when you go to do an oil change, you would notice on the bottom of your oil plug that nice little gray sludgy film. Yeah, that's your rings. That was your ring pack that was getting worn away and washed down to the end of the oil pan. But what we do is of course, the rough end, where we're trying to create the RVK, in which just think of V as a valley, and that's what it is. And that's where your oil has retention on the cylinder wall itself. If you are running different, and I think we've talked about this before, but just correct me if I don't know if we have or not, but if you're running a big turbocharger, your process or your approach for a high boost engine is quite a bit different than that of a production engine, because you have to increase the amount of RVK so that the oil basically stays on the wall. You're giving it more area for it to reside. And so if you don't come back though, and you don't plateau that, then what happens is that it's very aggressive and coarse, and the rings don't like it. It wears the rings out. So the right way to break an engine in is to do it first in the machining process. Hone it correctly with the right plateau procedure. Secondly is when you get your engine, a lot of idling. If you monitored your exhaust gas temperatures at idle, you might see 450 degrees, something like that. And as it's just sitting there idling, very low for a diesel engine. It's not like a gasoline engine where it'd be a lot higher. When you sit and you idle, you typically will have, and this especially on newer engines, you are allowing a lot more fuel to sit in certain areas of that cylinder. it's not burning it all off sometimes, especially if you have modified the piston. We have workhorse engines, and we do some modifications to the piston itself, and we do that for durability and reliability sake. But anytime that you lower the compression ratio of a piston, you are going to see a little bit of that effect take place. Letting it idle, though, for a long period of time can cause glazing of the cylinder wall. So it's best to go ahead and you want to put heat in the cylinder. You don't want it to sit there and just and idle for a long period of time. It's good to get out and drive the vehicle. What you're also trying to do is you're trying to understand the geometry. So you have the cylinder wall, and you have the ring that's contacting that, and then you have the ring land of the piston, and it's all trying to mate. It's all trying to mate together on the piston. So if I accelerate while I'm going down the road, where the location of that ring, it actually gets blown out towards the wall and pressed down. When I release off the accelerator, there is in between the second and the first ring, there's an accumulator groove on a lot of pistons. And what happens is it's like a two-way valve. And the intermediate ring now is, as I've let off the accelerator, the intermediate ring is keeping gases from coming back the other direction, right? So that's the reason why you have a keystone ring on the top, and you have different profiles for the rings on the top and the bottom, because one down here is basically keeping oil from being sucked back up into the cylinder, right? And it's getting expanded out. It's important that as you're breaking this engine in, that you don't want to do it at a constant RPM. And that's the reason why, is because you're trying to make the rings to the piston and the wall all at the same time. So at the same time, there are some guys that will tell you, go out there and hook it to the biggest load you can and pull it down the road. There's reasons why I do not agree with that, because you also have bearing surfaces at the same time that are trying to mate with the crankshaft. Now, they've been machined, they're new parts, they have not worn into a certain pattern. You've also got the camshaft that's wearing to the lifters. You've got a lot of parts that are mating to one another during that position. That's the reason why we encourage people to run their first break-in oil for the first 50 miles or whatever it is, 30 minutes, and dump it and get all that garbage out. I don't care how good you clean an engine, you are going to have some wear. You're going to have some wear material that's sacrificial when you press in a cam bearing. It is a press fit. So sometimes the material off of that cam bearing is going to wind up getting worn off, and you'll see it in the pan. All that stuff needs to get out of there as quick as you can. Running a break-in oil too long can be detrimental. And the reason why is because the break-in oil is designed to basically keep oil between the surfaces, and it is designed so that it basically brings it's not a detergent oil. I've heard a couple of different ways this is described, but it can cause things to accumulate in areas that you don't want them, and it can cause contamination, because the charge that's on the oil can cause contamination to stay in between the bearing and the surface. So you don't want that to happen. You want to disperse it, but not so much. It's a fine balance in what you're doing in that first part of the engine. Too great a viscosity on your break-in oil will not allow parts to wear in correctly, right? So you don't want an oil that's just extremely, for lack of a better term, repellent for wear. It has to have a certain wear characteristic. That's the reason why we were talking a little bit before about viscosities of oil and different things. That's the point of a good break-in package on your oil like that. So running the right oil and getting rid of it at the right time is really important. I'm starting to sound like Lake Speed here, but that's extremely important. You do want to put a load on the engine. You do want to put heat in the cylinder wall, but I would refrain from generally we use a 5 what do we call it? 5 and 5, something like that. 5,000 pounds, 5,000 miles kind of thing. Anyway, so that's generally the verbiage that we've adopted. So if you're going to be pulling heavy loads, more than 5,000 pounds, I would generally like to see, if you can break in that engine the first 5,000 miles and drive it go ahead, pull up to 5,000 pounds, fine, drive it around town. Now, some people can't do that, and I understand that. It's not the end of the world. That's just a preferred way to do it because it gives the bottom end opportunity to break in and all the components around it before you're putting them through a lot more stress. And I mean, with aviation, when we're talking air-cooled engines, I mean, it's extremely critical how they break in their rings, and a lot of things go wrong on that stuff. It's not as bad with what we deal with, and it's not like we're dealing with flat tappets and cams. We are on Cummins, but it's not like the days of the small block, big block stuff. So that's what we recommend.
So when somebody gets an engine from you guys, as far as that break-in package, do you guys, or the instructions, does it tell them what viscosity to run for that 5,000 miles, what type to do, and then switch over?
I'll let Adam.
We actually recommend driven racing break-in oil, a specific break-in oil that we sell. And then, yes, it says 50 miles on the break-in period. And then I can't remember, it's 50 miles. And then what do we split the oil change on the second one?
Yeah,
and then the third one's normal.
Right. We'll jump to a 500-mile oil change interval. And again, the purpose for that is just contamination. But to answer your question about certain viscosities, yes, certain engines will run certain viscosity. And the reasons for that is clearances. When we set and we design the engine to run a certain oil clearance. And, it also depends on the climate. It's very important to understand, the guy that's running in Alaska needs to make sure that he is running a different weight oil than the guy that's running in, Texas. There's quite a bit of difference. And these are all ISO standards. These are things that that's not proprietary to us. I mean, you can get online and you can find, if you look up what the pour factor of oil, basically the different pour factor ratings of oil, you can see what the suggested viscosity is in your climate and whatever temperature you're running. And oil is different. It reacts different. And when we say pour factor, that's just basically meaning that it's how quickly that oil will actually move or run at a certain temperature. And you start seeing oil at certain temperatures really change viscosity drastically, and you'll see the oil pressure just take a nosedive. So it's not like it stays, it's not like it stays one way and that's the way that it is. It definitely is blended to run at certain temperatures. And that's important. And because a lot of the protecting things in that package, a lot of the ingredients that are in that oil don't react until they reach a certain temperature. Transmissions are, Patrick, I know that you work with ATS and everything like that with transmissions, but the transmissions, the trans fluids are same way. We're seeing transmission temperatures now with fluids running, 200 degrees, and that's and plus, a lot higher than what they used to be. And that's because of the ingredients in the oil. It's designed to run a certain temperature.
My eco diesel actually will not allow full power until the transmission sees, I want to say 150 degrees.
Yeah.
It's actually got that built into the tune. But sorry, Patrick.
That's always one of the hardest questions we get, is because it's what type or weight viscosity should I run? And there's a YouTube channel I found recently. I can't remember the exact name of the channel. I think it's called The Truck Life, but it's a guy in Alaska who does these extreme long range trips. And I was watching it, and he's in this blizzard and it's minus 60 degrees, and he's got a 94 to 97 OBS power stroke. And sometimes he turns it off, sometimes he idles it all night. And I thought, that's probably the most extreme I've ever seen. But I want to ask him, what are you running to keep this thing that it fires up all the time? Because it does, it just runs. And that's a really common kind of question that people have. Something really interesting when we were chatting before the podcast was the engine dyno you guys got. And I wanted to ask about that because in my mind, I think of engine dyno, you're able to test before it goes out, verify everything meets all the data that you want to see on an engine. But I know someone who's listening to this is going to say, well, they just talked about break-in. Is the break-in done on the engine dyno, or is it not done? Do I still need to do all this? So I wanted to connect the dots on those two things.
Yeah, the engine dyno is going to do a lot of things for us, I think, and it should be here. We're hoping midsummer to get that, and be sure, little shameful plug here. Be sure to tune into our YouTube channel because there's going to be a lot of content that we want to go over, we want to discuss, and some things that almost like the Diesel Masters kind of started out being, and as we progress, keeping along the lines of the MythBusters of the diesel platform here. So it's going to give us an opportunity to do that. It's going to give us an opportunity to do testing on some of the new parts and stuff that we've got coming on. But as far as braking, yeah, it would be turnkey. You'd be ready to go. You do whatever you wanted to at that point in time. There would be no 5,500, or excuse me, 5,000 pounds, 5,000 mile kind of thing. But yeah, that's it. Just gives us a better understanding too of sometimes of the stuff that the tuning side of things. It gives us an understanding. We're not into tuning. We don't want to get into that. There's obviously too much going on with that right now, and I don't want to step off into that world. But it is important for our customers to know what effects, and it's important for us to know the effects of certain types of tunes on cylinder pressures, on engines, on bottom end stuff. There's a lot to learn from that. So I'm excited about it because it's going to be an education, and it's going to give me some insight and things that I have not had. And there's a lot of stuff. There's components that we're going to get to test. There's that they get talked about on the Diesel podcast, right? And we get to see for ourselves. Hey, this is what we're seeing off of it.
Well, that's something you've talked about before, Cass, is once you build an engine and it leaves your dock, it's a whole new world that it's going into, depending on what are they doing with injectors, what are they doing with turbo, what do they tow, how often do they service it, and there's so many different aftermarket parts and even new ones that are coming out with emissions compliant turbo kits and injection pumps and injectors and emissions compliant tuning. And I think people who are either they have the truck or they're looking to get one, they want to know, well, what happens if I run all these parts for 100,000 miles? What happens if I get the power up to 630 horsepower? Do I have wear on this? What happens? So I'm sure as an engine builder, that'll provide you a tremendous amount of data to be able to see, hey, is there a new series of engine I need to offer? Do I need to make a part for this? What's going to break? And so I imagine, gosh, possibilities are endless with the stuff you can come up with.
They are. And, we live in a world today that is social media driven, and there's so much misinformation out there that is just wrong. It's so wrong. I was watching something on one of the forums or one of the Facebook groups on the 7.3 stuff talking about the limit for connecting rods and different things like that. And there's so many variables that people don't understand. And this is going to give us an opportunity to do some testing with that. We're going to blow some stuff up intentionally on the camera so that we can see and show people this is the extent you can do it this way, you can do it that way. But it's now become that if Johnny ran his engine and he got 700 horsepower off of his forged rods and he made one pass and they lived, and he's running this big single charger, right? And this guy over here is running compounds. He thinks that he can run the same 700 horsepower off of these rods, which is insane, but whatever. I'm just throwing numbers out there. And I don't think that people really there's a lot of good data that we can get off the dyno with proper instrumentation. I'm not so much concerned with power levels necessarily as I am what the micro is doing. I want to know more about what the parts, what we're seeing. If we tore the engine down, we got guys all the time that'll say, well, my buddy ran this on a set of stock connecting rods. And the problem with it is if you tore the engine down at that power level and you start inspecting the rods, then you're going to start seeing that there's wear and there's a problem that your buddy didn't ever see, but we can show you on the film. And we're able to test that before we know from experience, but this way we can actually show that experience.
I think one of the cool things, so like this dyno is not supposed to be here until next month, right? Somewhere around that realm. I think one of the cool things that we've talked about is, so the dyno, when you're running it, it's generally only for a few minutes that the engine's running on it because it's creating heat. And that dyno has to be cooled down. One of the things we've talked about is upgrading that system to cool it down so we can run them for longer. And I'm really interested in that. There's something called a NATO test. It's what a lot of military engines go through a testing process. And I want to say, and I'm going to be totally wrong, I want to say a single NATO test is 400 hours. And it's like part of it has to be at 20%. Then they ramp up the power basically. Only certain dynos can do that. Now granted, the thing's not here yet, so I don't know how far close we'll get to that, but it could be kind of fun to watch an engine go through a very, very long dyno run and see how it fails.
Yeah, I mean, you're always fighting heat, like you say, and the viscosity at that point in time when your brake starts to heat up the water. And so we're hoping that we'll be able to outfit it so that we can do some prolonged testing. But it'll be great for us because, having the ability to manufacture in-house is awesome. I love that. I mean, I say it all the time, it wouldn't matter if I was a trillionaire tomorrow. I would spend it on all kind of machines. I just love machines. I'm a machine tool junkie. My wife they drive her nuts. But being able to test all that stuff that you're manufacturing and do it in a controlled environment and not on a truck. It's great to be able to test stuff on trucks. Don't get me wrong, but it's better if you could, your testing is controlled, and you can have repeatability through testing. Then that there's no skewed numbers anywhere, and that's really what it's about for us. And on top of that, we're also looking at expanding our current envelope of offering to the customers. We're looking at expanding into some heavier stuff, and this will allow us to do that. And turnkey packages. A lot of guys, consumers that they can't wait. They need this thing yesterday, and if we can provide a turnkey solution to them, that's our goal, to make it easy. Just a lot of these guys, they depend on these trucks for work, and you sell them an engine, and then they have to source all this other stuff, and then they have to wait for parts to come in, and then the part came in but it wasn't right, or the part came in and it was the wrong fitment or whatever it might be. This way, it's a turnkey solution to the guy, and he knows what he's getting. We can dyno test it. We can give him a power level. This is what you're wanting to hit. Great. This is what the engine's already been dyno tested, and it's done. So that's what it does for us.
Don't forget, diesel fans, make sure and head on over to Kershaw.kaiusa.com. Use code 2024 diesel40 for 40% off MSRP. It's a great way to save some money, get some really cool gear for EDC, hunting, fishing, around the job site, around the house. They've got a ton of different knives to choose from. You can pick from different opening mechanisms, blade steel, blade shape, handle design, and they have a whole lineup of knives designed to meet any budget. So use code 2024 diesel40, get 40% off MSRP. Also, Target Sports USA. It's a great company. I've been a customer of theirs from way before the podcast even started. So if you're into hunting, the outdoors, hitting the range, things like that, they've got a ton of inventory, ton of different brands, different options. And if you go to targetsportsusa.com/dieselpc, there's a special offer for you guys. So on your first order, you'll get a free cleaning kit, which is really cool to be able to get. Plus, they have a membership, which is really awesome. So when you join up, you get free shipping on any order. So whether you're ordering one box, 20, 50, 100, whatever it might be, you get free shipping plus an instant 8% discount. There's also different times during the year where that discount can get deeper. So that's just something that you automatically get. Now, some other benefits to that membership is when you sign up, you automatically get entered into a giveaway. There's two giveaways. The first is for hunting. So there's a hunting trip, all expense paid in Colorado. They take care of everything that you would need. It's a great experience, great way to be able to get out there. Maybe it's a hunt of a lifetime. I've always wanted to do it. So you're automatically entered for that. Plus, they do a truck giveaway. So every year they give away a Ford F-150. And I think the last person who won was a member for 7 months. Got the call, won the truck. So those are some added benefits to being able to join up. We appreciate their support in helping make the Diesel podcast popular. Plus all of your support out there. You guys who subscribe on YouTube, podcast apps, follow us on social media, Instagram, Facebook, TikTok. We appreciate all that support and look forward to bringing you guys more of the content that you want to hear in 2024. Until next time, keep the shiny side up.